Okay, so our remote session today is over section 1.8. We're going to continue some of the work we've done with equations and inequalities, but the little thing we introduce here is absolute value. So what happens when I have absolute value in an equation and an inequality? So absolute value, if you remember absolute value from previous work, you'll see something like this, the two vertical brackets. So the absolute value of 3, think of absolute value as you take the positive value. So the absolute value of 3 is 3. The absolute value of negative 3, you just make that positive, it's 3. So this is the distance, from 0. So the number 3, if you look at it, that is 3 units away from 0. The number negative 3, that is also 3 units away from 0 in a different direction. So when you think of absolute value, you think of it's always positive, it represents distance. So if I had something like this, the absolute value of x is equal to 3, that is asking for me what numbers are a distance of 3 from the origin, which is 0. So what numbers are 3 units away from 0? Well, the obvious one is 3. 3 is 3 units to the right of 0. But the one that you may not think of is also negative 3. So negative 3 is also 3 units away from 0. So when I look at the equation, how do I solve the absolute value of x is equal to 3? That has two solutions, x equal plus or minus 3. There are two numbers that are a distance of 3 from the origin. Now, we're going to look and see what happens when we have equations versus when we have inequalities. So in this case, let's look at the case where you have case number 1, an equation. The absolute value of some variable expression is equal to a number. The way you solve this is you just take plus or minus the number you have on the other side of the equal sign. So for example, if I had the absolute value of x plus 1 is equal to 4. Well, if I remove the absolute values, there are two numbers, plus or minus 4, that make that. So I'm asking, where is x plus 1 a distance of 4 from the origin? Solve this for x. X is equal to negative 1 plus or minus 4. So x is equal to negative 1 plus 4 is 3. Negative 1 minus 4 is negative 5. Those are the two solutions to that inequality. Now, the cases where you see absolute value of x is less than a number. That means what numbers are less than k distance away from the origin. So you got some number k and minus k here, okay? The numbers that are that distance or less than that distance away would be all the numbers in between. So any number out here, this is more than k units away, okay? So it has to be all the numbers that are in between, and we'll talk about solving that. Then the other case we're going to have is the absolute value of some number is greater than another number. So that means what numbers are greater than k away from the origin. This is more than k away, this is more than k away. This number is less than k away, so it's not in my solution. So what you see in the first case, you're going to have two numbers as your answer, okay? In this case, you're going to have an interval, so you see that interval there. And in this case, you have two different intervals as your solution. So we'll talk about how to solve those as we go forward. So let's solve a few equations. So your key here is isolate the part that has the absolute value. Get the absolute value by itself, okay? So 5 minus 3x, absolute value of that is equal to 12. If I take the absolute value sign away, then I get plus or minus 12, okay? So I'm finding things that are, where is 5 minus 3x a distance of 12 away from the origin? Well, it could be positive 12 or negative 12. So that's how I get this plus or minus. Now it's just solve this equation for x. So I have negative 3x is equal to negative 5 plus or minus 12. So negative 3x is equal to negative 5 plus 12, that's 7. Negative 5 minus 12, that's negative 17. So to solve this for x, you're going to have to divide everything by negative 3. So you get two solutions for this. And we double check our answer, negative 7/3 and 17/3, which is what you see there. Okay. Now what you could do, if this plus or minus confuses you, you could just do the problem like this. 5 minus 3x equal 12. 5 minus 3x equal negative 12. Break it into two problems. This might be an easier way to do it. So that means negative 3x equals 12 minus 5. Negative 3x equals 7. X equal negative 7/3. And then over here, negative 3x equal negative 5 minus 12. Negative 3x equal negative 17. X equal negative 17 over negative 3. X equals 17/3. Okay, either way. And we've done that. So let's look at the next problem. Here I've got trying to confuse you with two absolute value signs. So the absolute value of 4x minus 3 equal the absolute value of x plus 6. So to get rid of the absolute value sign, 4x minus 3 is going to be x plus 6, or 4x minus 3 equal the negative of that. So I'm taking the absolute value sign on the left. It equals plus or minus what I have on the right. So on this first problem here, so let's sort of divide these. If I subtract x from both sides, I get 3x minus 3 equals 6. Add 3 to both sides. 3x equal 9. X equal 9/3. X equal 3. So that is one of my solutions. If I look at the solution over here, I get 4x minus 3 equal minus x minus 6. Add x to both sides. 5x minus 3 equal negative 6. Add 3 to both sides. 5x equal minus 3, or x equal minus 3/5. So those are our two solutions. Now, when it comes to an inequality, this one, the easiest thing to do here is to break this into two problems, okay? When you've got the absolute value and you've got a positive number here, we can break this into two problems, okay? So here's how we're going to do this. So 2x plus 1, absolute value, is less than 7. So I want to create two different problems here. First problem, write down everything just like it is, but skip the absolute value sign, okay? That's the first problem. Next problem, I want you to 2x plus 1, and you make two changes. Whatever that inequality sign is, flip it. And then whatever the value is for that number, you make it minus. So create two different problems here. First problem, copy everything down just like it is from the problem without the absolute value sign. Next problem, start out copying everything, but make two changes. Whatever the inequality sign is that you see here, make it the opposite. Whatever the value of this number is, make it the opposite. Now solve these two equations. So over here on the left, I'm going to get, if I subtract 1 from both sides, I get 2x is less than 6. Divides both sides by 2, x is less than 3. Okay. Over here, if I subtract 1 from both sides, I get 2x greater than minus 8. Divide by 2, and I get x is greater than negative 4. Okay. So that is my solution. All the numbers that are less than 3 or greater than -4. A number line is a very useful tool for seeing this. What are the numbers that are less than 3? Those are these numbers. What are the numbers that are greater than -4? Those are the numbers that start at 4 and shade to the left. So this interval is all the numbers from -4 up to 3. That is the solution for this inequality. So again, when you have these absolute value inequalities, your key is to break it into two problems. You'll get the solution. A number line is a useful visual to see that, and then you write in interval notation what the solution is. 2x plus 1 is greater than 7. So do the same thing. 2x plus 1, absolute value, is greater than 7. We're going to break this into two problems. First problem, write down everything you have just like it is, but without the absolute value sign. Okay. Next problem, start writing down just like you have it, but make two changes. Instead of greater than, make it less than. Instead of +7, make it -7. Now we go solve both of these equations. Subtract 1 from both sides. 2x greater than 6. Divide both sides by 2. X is greater than 3. Okay, that's half of my solution. Look at the other problem. Subtract 1 from both sides. 2x less than -8. Divide both sides by 2. X is less than -4. So numbers that are greater than 3, less than -4. Number line, a good way to draw this. So you've got numbers that are greater than 3, they look like that. Numbers that are less than -4, they look like this. I see two intervals right there. All the numbers from, so this interval is -infinity up to -4. And this is a fancy thing for or the numbers from 3 to infinity. Okay, so that is your solution. All the numbers from -infinity to -4, or all the numbers from 3 to infinity. So again, absolute value thrown into an inequality. So 2 minus 7x absolute value less than 1 greater than 4. So what I really want is I need this to be all by itself before I can do anything. What's keeping it from being by itself right now? That 1. Add 1 to both sides. So 2 minus 7x is greater than 5. Now break this into two problems. 2 minus 7x greater than 5. Just copy down everything like you have it without the absolute value. And then make another problem. 2 minus 7x. Instead of greater than, make it less than. Instead of 5, make it a -5. Now solve both of these problems. Okay, so in order to do this, if I subtract 2 from both sides, I get -7x is greater than 3. Now I'm going to divide by -7. Keep in mind, whenever I divide by a negative, I change an inequality. So this becomes x less than -3/7. And then over here, if I subtract 2 from both sides, I get -7x less than -7. When I divide by -7, it's going to change that inequality. X is, instead of less than, it's going to be greater than 1. So what are all the numbers that are less than -3/7 and greater than 1? Here's 1. Here's a -3/7. To be less than -3/7, that's this situation. To be greater than 1, shade to the right, those are two distinct intervals. Okay, so this is the interval from -infinity to -3/7, or the interval from 1 to infinity. Okay, so again, these are linear. The catch that's thrown in is the absolute value. So you got to know how to break them into two separate problems. Now, every problem we had so far, what you saw on that inequality, you saw a positive number over here, okay? So this is sort of the trick question. 2 minus 5x is greater than negative 4. So let's look at this. 2 minus 5x, absolute value, greater than or equal to negative 4, okay? The way to think about this is negative 4 is what kind of number? That is a negative number. Okay. The absolute value of anything. What is the absolute value? It means it's a what kind of number? It's a positive number. Okay. So this is always positive. Then the question becomes, what positive numbers are greater than or equal to negative 4? All of them. Okay. This is always positive. The right side is always negative. This will always be true. So this is for all. This is true for all real numbers. So the solution is negative infinity to infinity. So it boils down to what positive numbers are greater than the negative numbers, all of them. Now look at the situation here, a little bit different. 4x minus 7 is less than negative 3. This is a negative number. This is a positive number. Are there positive numbers that are less than negative 3? So like negative 5, negative 7, those aren't positive numbers. There's no solution to this. So this is sort of the trick question. Anytime you see absolute value inequalities and you got negative numbers over here, you're going to have one of the situations where the solution is all real numbers or no real numbers. And you've got to be able to put a little bit of intuition or thought into that process. Another special case, 5x plus 15 is equal to 0. Okay. The way we typically solve this, we would say 5x plus 15 is equal to plus or minus 0. Well, that doesn't mean anything, plus or minus 0, okay? Because 0 has no sign. So this is just 5x plus 15 equals 0. Move the 15 to the right. 5x equal minus 15. X equal negative 15 over 5. X equal negative 3. So there's only one solution when you have an absolute value equal to 0. Okay. Now let's look at this in the context of me giving a description. K is no less than 5 units from 8. So what does it mean? K is no less than 5 units from 8. So 4 is, or let's just say 7. Well, let me back up. So K is no less than 5 units from 8. Okay, so if you think about it, on a number line, you've got an 8. And I'm saying it is no less than 5 units away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm talking about the situation where I'm talking about things out here. So that's what I'm trying to model. It is no less than 5 units from 8. So the way I look at this from an absolute value standpoint, you look at this is my distance away from 8. Okay. And I'm saying it is no less than 5 units. That means it is 5 or greater. So the distance from 8 is greater than or equal to 5. Now, to prove this, what was this? 1, 2, 3, 4, 5. This is 13. And 8 minus 5 is 3. Let's try to solve this. X minus 8 greater than or equal to 5. X minus 8 less than or equal to negative 5. Add 8 to both sides. X is greater than or equal to 13. That's what we see right up here. Add 8 to both sides. X is less than or equal to 3. That's what you see over here. So that solution is negative infinity to 3 and 13 to infinity. Okay. write this statement in terms of an absolute value. N is within 0.001 unit of 6. So I'm talking about the distance from 6. So N minus 6, I'm talking about that distance. It is within 0.001. So it is less than 0.001. So N minus 6 is less than 0.001. And I'm going to skip the word problem here, and we should be good to go. So again, the summary of what we did in this section are how to solve expressions with absolute values that are equal sign. So anytime you see something like 2x plus 7 minus 1 equal 4, in order to solve this, you want the absolute value to be by itself. How do I get it by itself? Add 1 to both sides. So 2x plus 7 equal 5. To take the absolute value away, then I'm going to get two answers. 2x plus 7 equal 5, or 2x plus 7 equal negative 5. Now solve both of these. You take 7 away from both sides. 2x is equal to negative 2, x equal negative 1. That's one solution. Here, subtract 7 from both sides. 2x equal negative 12. X equal, if I divide by 2, negative 6. Okay? That's the way I handle absolute value with an equality. If I've got an inequality, so I've got something like 2x plus 1 is greater than 4. Well, I need the absolute value by itself. That's what I have. And I break this into two problems. 2x plus 1 greater than 4. 2x plus 1. Make two changes. Switch that from a greater than to a less than, and make that a negative 4. Now solve both of these problems. So if I subtract 1 from both sides, 2x greater than 3. X greater than 3 halves. Okay, that's half of it. Here, subtract 1 from both sides, 2x less than negative 5. X less than negative 5 halves. So numbers that are, if you look at negative 5 halves on a number line and 3 halves on a number line, I'm looking for numbers that are greater than 3 halves, numbers that are less than negative 5 halves. That shows me two distinct intervals. This is the interval from negative infinity to negative 5 halves, or the interval from 3 halves to infinity. And that is the solution. Okay. And then the other kind of problem would be very similar, would be just something with a less than. So if I had 2x plus 3 plus 1 is less than 6. Okay. What I need in order to work on this, I need that absolute value to be by itself. So subtract 1 from both sides. 2x plus 3 is less than 5. Now break this into two problems. First problem, 2x plus 3 less than 5. Second problem, 2x plus 3 greater than negative 5. Now solve both of these problems. So 2x is less than 2, x is less than 1. Next problem, subtract 3 from both sides. 2x greater than negative 8. Divide both sides by 2. X is greater than negative 4. So negative 4, 1. Numbers that are greater than negative 4, less than 1. That is one interval. That is the interval from negative 4 to 1. Okay? And that should be it for this section. So this is 1.8. This is the last section that you have, and the next time I see you is the unit test over all of Unit 1. So you've got homework from 1.5, 6, and 7 from last night, and then this homework from Unit 8, 1.8, short quiz on 1.8, and then we have our unit test the next time I see you.